Okay, we're ready for difference quotients 2. Type 2 is going to be using the fact that the product of conjugates is always a difference of squares. That is, when you do first plus last as a sum and then first minus last as a difference, you always get f squared minus l squared. But now what we're going to have is the square root of some stuff minus some junk, and we're going to have to apply to it the square root of some stuff plus junk, which gives us the square root squared, which is just stuff minus junk. So the first example, f of x equals the square root of x plus 12. So f of x plus h, I just insert wherever I see the x, I put the x plus h, and I set up my difference quotient, f of x plus h minus f of x over h. So here's the original problem. Now I kept it clean, but you all would immediately not just do that step separately, but you would say, oh no, look, I'm going to have to use the conjugate, so you don't write this and then this. Don't do that, please. No one does. Maybe a textbook, but nobody else. So I multiplied by the conjugate. Now what's true? The denominator is going to remain pregnant. Nothing happens, but the numerator, I'm going to get a quantity minus a quantity. And just like before, x minus x, this will be gone. And 12 minus 12, that will be gone. And all that's left is h. And so now I'm allowed to simplify, and now my h's are gone, and I'm left with this lovely quantity. Now, if I had been doing this as a limit, that is putting the limit as h goes to 0 here, what would happen is this h would disappear, and I had 1 over twice the square root. Every single time, folks. Every single time. Example 2. Well, does it change just because I subtract a constant? And of course not. Wherever you see the x, you're going to put the x plus h. And so I've set up my difference quotient, which is the square root of x plus h minus 7 in the radicand, minus the square root of x minus 7 in that radicand, all over h. Again, you don't write that separately. You immediately apply the conjugate because you're going to rationalize the numerator. So we're going to use the sum. The denominator we leave factored because we're going to cancel. The numerator, you're going to get the quantity squared minus the quantity squared, which is just the contents of the radicand. And again, I'm going to combine similar terms, x minus x, a negative 7 minus a negative 7. I'm left with h, and now I can cancel my h's. And I'm left with 1 over. Notice, again, had I done this as the limit as h goes to 0, and then we would see all this as 0 over 0, which is why we're doing more algebra, this h would disappear, and my answer would just be 1 over 2 of these. Now, hopefully that you've noticed, just as with our polynomials, when the square root symbols are removed, that the terms from the radicands stay in their same position. This means that the x plus h stuff stays first and the x stuff stays last. This will always be true when we rationalize our numerator. Now, I want to just tell you something else that many of you don't know unless you have a really dippy calculator, because our calculator doesn't put the parentheses in it. It just leaves it this way when we put it together. But when you see a radical, you must always simplify the radicand first. I don't get to do square root 1 plus square root 15. I have to add it up and call it 16. That means that this radical symbol means the same as this radical symbol. It means order of operation is do the radicand, then do the radical. So this means that it's always simplified first, the radicand, And a parenthesis is understood and is always required if you have more than two terms in the radicand when you do a radical square, the square root squared. So, just reminding you a little bit about order of operation for those of you who are a little lax on it. So our next problem, oh my, look, I'm subtracting the x now. What's going to happen? Well, the f of x plus h, I'm subtracting it. And remember, this is linear. Whatever the x gets, the h gets. And so they both have to have a negative sign. So I set up my difference quotient, and I have the square root. And in its radicand is 5 minus x minus h, minus another square root, whose radicand is 5 minus x, all over h. Now again, you all don't need to write that separately. That was teaching. And so I'm going to use the conjugate, which is the plus. The denominators I'm going to leave factored. The numerators I'm going to multiply. What happens when you have f minus L times f plus L? You get f squared, which is just the radicand. You get L squared, which is just the radicand in their appropriate parentheses. Now, we're going to simplify, and 5 subtract 5 is still 0. And a negative x minus a negative x is still 0. But now I have a negative h. So when I go to cancel my h's, I'm going to have a negative 1, not a positive 1. And if this really did say limit, then this h would disappear and you would have two of those radicals. And your answer would be negative 1 over 2 times that quantity square root. The last example, let's put some meat on it. And let's have the square root of 8 minus 7x. And so f of x plus h, I'm going to have to distribute negative 7 times the x plus h. Again, the x is linear. That means the x and the h have the same coefficient. I set up my difference quotient. Notice you don't have to write that step. I'm going to apply the conjugate to the numerator and denominator as a form of 1. The denominator I'm going to keep factored. The numerator I'm going to go ahead and multiply. The quantity squared is just the radicand. The quantity squared is just the radicand. Notice the parentheses are not optional. 8 minus 8, negative 7x minus the 7x when I combine. So I now have a negative 7h left. I can now reduce this h, kills that h. And what's the difference? Oh, if x has a coefficient, whatever x's coefficient, have you noticed it's in the numerator? The coefficient of x was negative 7. Lo and behold, negative 7. The coefficient of x was negative 1. What's in the denominator? Negative 1, and these were boring. I'm only going to show one of them. The coefficient of x was 1, and so I get a 1. Yes, folks, that is indeed a pattern for those of you that are interested in patterns. And again, I'm going to actually show it this time. I'm going to say, what if I let h go to 0? Well, then you're just going to mark out this h. Because when you evaluate, oh, I get 2 of these. And this is exactly what happened when we had numeric answers on worksheet 7. Okay, only you had like 2 square root 7 or 2 square root 8 or, 11 or something like that in the denominator.